Okay, guys, welcome to the exam style questions. If I can get my words out, exam style questions for our nth term. So this is going to be very similar to the one we did before, but just a continuation, something that has come up in exams before, just to give you guys that extra practice that you need. So, looking at question 6, we're given 5 terms in the sequence 17, 14, 11, 8, and 5, and they tell us to find the next term in the sequence. So, we can clearly see that from each term, it's going as minus 3, minus 3, minus 3, and minus 3. And to continue on the sequence, they want us to find the next term. So, we're going to have to minus 3, continuing the pattern, and get 2. 2 is the next term in the sequence. The nth term of a different sequence is 10 n squared plus 5, and they tell us that we need to work out the fifth term in this sequence. So the way we do this, we plug in our n is equal to 5, which we learned in the revision episode of this topic. So plug in 5 squared plus 5. Hence the n is being squared. We first square that, so 10 times by 25 plus 5, which means this is 250 plus 5. 255 is our answer in this case. Okay, looking at the next question, we're given 4 terms in a sequence 2, 3, 5, and 9. The rule to continue the sequence is multiply the previous term by 2 and then subtract 1. So, and we were asked to work out the fifth term of this sequence. Okay, so we've got our first 4, 1, 2, 3, 4, and we want to work out our fifth term here. And the rule is to multiply the previous term. In this case, it will be our fourth term, which is 9 by 2, so 9 times by 2, and then subtract 1. So this gives us 18 minus 1, which is 17. Okay, here is a sequence of patterns made from white tiles and grey tiles. In the space below, draw pattern number 4. Okay, so this is more of an abstract question where it's more using your intelligence outside of what we learn in maths. So we can clearly see that the shapes are getting longer. So there's 4 here, 3 here, 2 here, and the number of grey shaded circles is also increasing from 1 each side, 2 each side, 3 each side. So to draw the next one, just do this 1, 2, 3, 4, and there's 4 in that one, so you got one more, 5. Then we draw our shaded ones, and that should complete our pattern. I'll just shade these in now. Yep, that completes it. Work out the number of tiles to make pattern 7. So, okay, the way we'd approach this question is to see, okay, fine. We can see that pattern 1, it takes 4 tiles to make the design. Pattern 2, 1, 2, 3, 4, 5, 6, 7. 7. Then we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to make pattern 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 to make our pattern 4. And this is, I hope you guys spotted it. It's making a linear sequence. And each time the terms are going up by 3. So we do our 3n, then we do our inverse at minus 3 and get our 1. So the nth term is 3n plus 1, and we want to see how many are needed to make pattern number 7. So we plug in our n is equal to 7. 3 times by 21 plus 1 is 63 plus 1, which is 64. Okay, Kyle says there are 4 white tiles in pattern 3, So there'll be 8 white tiles in pattern number 6. Is Kyle right? And we must give a reason. So he says there's 4 white tiles in pattern number 3, as you can see at the top there. So there'll be 8 white tiles in pattern number 6. Okay, so we can clearly see that the white tiles are increasing by 1 with regards to the pattern number. So pattern number 1, and then white tiles, we see there's 2 in pattern number 1. In pattern number 2, there's 3. In pattern number 3, there's 4. And pattern number 4, there's 5. So hence there are 4 white tiles in pattern number 3, which means it contradicts his statement of saying there's 8 white tiles in pattern number 6, because we know that with regards to the pattern numbers, it's increasing by 1. So pattern number 6 should have 7 white tiles. Hence, Kyle is wrong. Okay, looking at the last exam question today, it gives us 5 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of this sequence. So I'm going to write this out here just to give me a bit more space to show you guys. Each time we're increasing by plus 4, plus 4, plus 4, plus 4. So we know our first part of our formula is going to be 4n. Then we do our inverse, minus 4, to work out the term before our first and get our minus 7. 4n minus 7 is the expression for our nth term. So the nth term of a different sequence is 2n minus 3. Is 101 a term in the sequence? We looked at this in the revision series. If you haven't checked that out yet, please do go check it out before you do these exam questions. It will be very helpful for you. So we want to equate our 2n minus 3 and our 101 and solve the equation. So 2n plus 3 on both sides is equal to 104. Divide both sides by 2. We get n is equal to 52. So this proves that 101 is a term in the sequence because we've got a whole number for our n. So that concludes it, and we can say that, yeah, 101 is the 52nd term in our sequence. Alright guys, I think this is going to end on our exam style question series for nth term. Hope you guys enjoyed, hope you guys learned. Be sure to check us out on our other socials and like, comment and subscribe. I'll catch you in the next one.